Hello everyone. Welcome back to the channel. Today we are going to understand an important topic in analog electronics, analog to digital converter or ADC using op-amp. Have you ever wondered how your microphone, temperature sensor or mobile phone converts real-world signals into digital data? That conversion is done using ADC. And in many ADC circuits, op-amp plays a very important role. So let's understand this concept step by step in a simple and clear way. Introduction. Our topic is analog to digital converter using op-amp. ADC is a circuit that converts analog signals into digital signals. Analog signals are continuous in nature. Digital signals are discrete, mostly in binary form, 0 and 1. In modern electronics, most systems like microcontrollers, computers, and digital processors work only with digital data. So conversion is very important. What is an ADC? An analog to digital converter is an electronic circuit that takes continuous analog input, converts it into digital binary output. Why do we need ADC? Because microcontrollers understand only digital signals. But real-world signals like sound, light, and temperature are analog. Examples include temperature sensors, microphones, light sensors. So ADC acts as a bridge between analog world and digital world. Role of op-amp in ADC. Now let's understand the role of op-amp. Op-amps are used in ADC circuits as comparator, signal conditioner, buffer amplifier. The main function is to compare the input analog voltage with a reference voltage. This comparison helps in generating digital output. Without comparison, digital decision is not possible. Comparator using op-amp. An op-amp without feedback works as a comparator. Working principle is very simple. If Vin is greater than Vref, output becomes plus VCC. This is considered logic 1. If Vin is less than Vref, output becomes VCC. This is considered logic 0. So the op-amp compares two voltages and produces a digital type output. This is the basic concept behind ADC operation. Simple 1-bit ADC using op-amp. A simple 1-bit ADC can be made using one op-amp. Main components are op-amp, reference voltage, analog input, power supply. When the input voltage crosses the reference voltage, the output switches between high and low. Since output has only two levels, 0 or 1, it is called a 1-bit ADC. This is the simplest form of ADC. Flash ADC using multiple op-amps. Now let's move to Flash ADC. Flash ADC uses multiple comparators, voltage divider network, encoder circuit. Each comparator compares input voltage with different reference levels. The outputs are then given to an encoder. Encoder converts those outputs into binary form. Advantage of Flash ADC: very fast conversion. Disadvantage: requires many op-amps, especially for higher resolution. So hardware cost increases. Successive Approximation ADC. In Successive Approximation ADC, op-amp is used in comparator stage, sample and hold circuit. Working steps. First, input signal is sampled. Then it is compared with DAC output. Digital value is adjusted step by step. Finally, the correct digital value is generated. This method is slower than flash ADC but requires fewer components. Basic block diagram. Basic blocks of ADC are analog input, comparator op-amp, reference voltage, encoder, digital output. The input is compared with reference. Decision is taken. Binary output is generated. This is how analog signal becomes digital. Applications. ADC is used in many practical systems. Microcontroller systems, digital voltmeters, audio recording systems, communication systems, medical instruments. Without ADC, modern digital electronics would not work. Advantages. Some advantages of ADC. Converts real-world signals into digital form. High accuracy. Easy to interface with digital systems. Flash ADC provides very fast conversion. Limitations. There are some limitations also. Requires precise reference voltage. Noise affects accuracy. Flash ADC needs many op-amps. So design should be careful and accurate. Conclusion. Let's summarize. Op-amp plays a very important role in ADC circuits. It mainly works as a comparator. It helps in comparing input signal with reference voltage. Based on comparison, digital output is generated. ADC is essential in modern electronic systems. Without ADC, communication between analog world and digital world is not possible. If you found this video helpful, like the video, share with your friends. Subscribe to the channel for more electronics concepts. And comment below which topic you want next, DAC, sample.